Singularity.
My name is Nicola, and you're watching Singularity FM, the place where we interview the future. If you guys enjoy this podcast, you can help me make it better in one of two ways. Number one is you can go and write a brief review on iTunes, or number two is you can go to interviewthefuture.com and simply make a donation. Today, my guests on the show are Laura Major and Julie Shah. Laura Major is CTO of Motional, previously Hyundai Aptiv autonomous driving joint venture, where she leads the development of autonomous vehicles. Previously, she also led the development of autonomous aerial vehicles at Sci-Fi, which is a division at Draper Laboratory. And basically, just for clarity, those autonomous aerial vehicles are basically tethered drones, if I get this right. Is that correct, Laura?
That's correct. But Sci-Fi is not a part of Draper. Sci-Fi was one position that I held, and then I was a division leader at Draper Laboratory as a separate part of my career.
Okay, I apologize. My bad. I'm just reading here the bio that your PR person shared with me. So I apologize for that. But Julie Shah is a roboticist at MIT and an associate dean of social and ethical responsibilities of computing. She directs the Interactive Robotics Group in the Schwarzman College of Computing at MIT. Does that sound about right, Julie?
That is right. Thanks.
Fantastic. Okay, excellent. So, and of course, the reason why we are here today with Laura and Julie is not only because they're experts in topics that we traditionally discuss on Singularity FM, such as robotics and artificial intelligence, drones, etc., but also because they have an interesting new book that recently came out called What to Expect When Expecting Robots. So, Laura and Julie, welcome to Singularity FM.
Thank you.
Yeah, it's great to be here.
Fantastic. So, let's say that we were in the good old days that we had this ancient archaic thing called a conference, in-person conference, and we were to meet somewhere in the halls of that conference. And I never knew anything about you, never read your book, which of course I read your book and I watched your TED Talks. So how would you introduce yourselves in a sentence or two to someone who's never heard of you before? Perhaps Julie can start.
Sure, I'm happy to start. So I'm a professor at MIT, and I'm an AI researcher and a roboticist. And my team and I, we focus on developing AI that's able to model people to make robots better collaborators, better able to integrate into human teams and work with us. And so in a short phrase, that's what I spend the majority of my time thinking about and working on.
Fantastic. And can you tell me a little bit more about, because you're an associate dean of social and ethical responsibilities of computing. So I can see how you have the sort of the roboticist end of things, but where does the social and ethical part of your expertise come from, or interest, if you will?
Yeah, so I can talk a little bit about my interest that led me into that role. So I've worked for many years in robotics for manufacturing. So developing and deploying robots that collaborate with people, that work alongside people to build planes and build cars. When we think about introduction of these technologies and future of work, there are very, very substantial social, ethical, policy implications and considerations. And one sort of framing of one sort of motivation for it is to think about how we can be intentional about doing things differently. So rather than thinking about deploying robots that replace people, thinking about how we can enhance or augment human capability and well-being. And so I could talk more about that at length, but obviously the challenges that we have, of course, are related to future work, but also many other social, ethical considerations just with computing more broadly. And so it's sort of a responsibility for all of us to think about how we grapple with the impact that these technologies can have, the scale of their impact and how we bring that back, as technologists on my part, thinking about, how that influences how we conceive of technologies, how we design them, thinking about impacts and testing and deployment. So it's something I'm very passionate about.
Yeah, and so we are together for that reason too, because the whole point of my show for the past 11 years has been precisely that. Not so much the how, but the why, or even the so what. Like why we should use something, and then so what happens after we've used it. The how, to me as a philosopher, the how has always been an interesting sort of an engineering technical detail, but the bigger questions are always why or so what. But it's time to bring Laura into our conversation. So Laura, how would you introduce yourself in a couple of words? Who is Laura Major?
Yeah, so I'm an engineer, and I've been focused on designing autonomous systems in a way that can better collaborate and interact with people for my whole career. This started at Draper Lab, where I did this for industrial applications, then expanded at Sci-Fi, where we focused in on a specific product that we were moving out of military applications and into broader industrial applications. And now, as the more that I focused on that topic in these industrial environments, I saw the opportunity to take the lessons that we had learned over decades across aerospace applications in factories, take the lessons we learned there and the techniques we learned there, and use those to help in the commercial sector, where we're now starting to bring these robotic and autonomous system capabilities into helping everyday people. And so this is what led me ultimately to autonomous vehicles and to my current position at Motional, where I'm the CTO leading our engineering development, our technology strategy for creating, a commercial driverless system.
So you decided that drones are kind of not a big enough challenge for you, and therefore decided to go with cars, which to the non-expert like me seem to be much, 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 much harder to make than drones. Is that not the case?
So I wouldn't say I left drones, because I thought cars were harder. It was more an evolution, I think, kind of my own personal journey. Again, I had focused in industrial applications for a long time, looking at space applications for autonomy, looking at drones. But I'm an aerospace engineer as my background. But ultimately, I saw this opportunity growing in the consumer space, and autonomous cars was, is one example. But I think we see delivery robotics. We're seeing cleaning robots, sanitation robots. Broad spectrum. But I saw this opportunity again. I had been deeply working in the industrial sector, and again, we had a lot of lessons learned there, that I saw some of the same mistakes happening in the commercial sector that was trying to, adopt and really progress some of the technology that we've been using for decades in say, aerospace. I saw some of those same mistakes happening. We cover them in our book. And so that ultimately the book project is part of what led me to want to go into autonomous driving, to help make sure that we do it right from the start, and that we don't just create an autonomous system. We create a safe autonomous system that's going to integrate with the people that are going to inevitably surround it. So that was I was drawn to that, to move out of the industrial sector and into the consumer side, because I saw that I had a lot to bring, and a lot of again, hard learned lessons that I thought could make a big impact on this new area.
Okay, so let's talk a little bit about the big picture of artificial intelligence and robotics, and then we can sort of zoom in and narrow it down to see what we can expect when expecting robots, and see how that book and the ideas in that book kind of fit within that big picture. So now, first of all, let me ask you, and this time we'll start with Laura. Let me ask you, what do you ladies, as experts and professionals with years of experience in the robotics and AI industries, think that are the major challenges or problems or big issues that we are grappling with right now within, let's say, robotics or even artificial intelligence?
Yeah, wow, that's a big question. There's a lot that we're grappling with. But But I think, I think the real crux of the question that you're asking is, what are some of those barriers that we have to break through to get to the other side where this can become more of a reality and less of a proof of concept? And so for me, that comes down
Well,
to
let me just interrupt for 1 second
yeah,
here. So the reality part of it, or how to make it a reality, is one issue, and that's the sort of the engineering challenge. But I'm thinking also about the challenge posed to us by people such as Elon Musk. He says that creating an AI is like calling in the demon. Dr. Stephen Hawking said that it's the end of the human race. People such as Bill Gates, Steve Wozniak, and many others have made headlines around the world with similar, snippets. Some of them taken out of context, but many of them adding up to the same thing. So at least it would seem that one of the big issues, before we get to how to do those, is whether we should do those, whether that's a good thing, a reasonable thing, or ultimately a suicidal, self-defeating thing. Because Elon Musk was talking about the horror movies where a bunch of kids get together to call in the demon, and that was the metaphor that he used in talking about artificial intelligence.
Yeah, I can jump in. I think if that's okay, yeah. I mean, I think there's unease about what this technology can do and what it can become, and I think that's well founded. I mean, we really need to be grappling with these issues right now, and there are these sort of existential questions. And there are these sort of more grounded, near-term potential threats that this technology poses too, and we would do good by working through as we are and trying to address both of those right from the sort of earliest part of the development of these technologies. I think for me, it comes down to asking the question of, well, what is AI suited to, and what is our human our human ability that's really unique, and at least in my personal opinion will remain unique for some time. I think one of the key distinctions is that our unique human ability is to take an unstructured problem and structure it. Once we have a structured problem, AI can like crush it. But it's very easy to overlook all of the ways that we structured the ability of AI to solve many of the problems it's solving today. From labeling data, that's structuring the machine's understanding of the world. From the ways in which we choose to collect data, that's structuring the machine's problem of the world. And just to bring that in the context of a robotics problem, you're recognizing objects in a scene when it's sort of framed by a person taking a picture. We naturally frame objects of interest, right? But you let a robot roam freely around and you try to identify objects in your home. The video stream is not framed to attend to aspects that are important to us, and the problem becomes much harder. So we structure these problems for AI and for robots today in ways that sometimes we don't fully really appreciate. And so I think the real question for me is one, like how do we become intentional about structuring problems for AI so that they can help us in new areas where we urgently need help, not just where it's easy to use them currently. And then how do we develop AI and robots? Like how do we conceive of their use in a way that's of value to us, and break free of this idea that this is technology that's just on some unmodifiable path, and we just have to deal with the consequences of what unfolds, because that's absolutely not true. We frame the machine learning problem to start with. We frame the robotics problem to start with. And so, yeah, that's my short answer.
What
to
about
that
you, Laura?
question.
Yeah, that's a great answer, Julie. And if you'll see in our book, we cover that topic, and Julie and I think have been talking through that topic for years now of how can we further, add more structure to our world and more structure to our technology to allow, these solutions to take on those tasks that maybe are hard for us to do. Driving is a good example where there are still, a large number of fatalities due to, drowsy drivers or drunk drivers. Autonomous vehicles offer the opportunity to, avoid that, or to reduce the number of fatalities on our roadways. But it does require, exactly as Julie describes, this intentional structuring to make the problem solvable by a machine. I think both Julie and I feel like, it's not about AI taking over every problem in our world. It's really about, again, designing these intentional solutions that address things that are hard for people to do, and designing them in a way that can collaborate with people, so that people can continue to provide that structure, that direction, that guidance to the robotic system, the AI system. But it's about, that sort of complement between people and the automated and autonomous technology.
So I get that you're both for sort of enhancing ourselves rather than replacing ourselves, and your book talks a lot about that, and we'll get into that in a minute. But just to be clear, so you think that those kind of concerns are overblown or unrealistic? Perhaps you agree with, I think it was Andrew Ng who said that worrying about the danger of AI is like worrying about overpopulation on Mars.
I would not say they are overblown. I think it's a danger for us not to be asking these questions and be concerned about them right from the beginning. I personally am deeply concerned about the near-term challenges we're going to see, not the sort of existential threat, but the near-term threat of our sidewalks sort of blanketed with systems that don't understand us as anything much more than kind of objects, and the safety risk posed by these systems when we don't design for them, and don't design them specifically to integrate and understand our norms and the ways we are human in our everyday world. I think we need everybody worried about all of these things and thinking about constructive ways to move this from worry or talk to bringing the right people at the table to understand how we address these challenges. But our book is very much focused on these sort of near-term challenges of integration of the technology, and how we can maybe leap over some of the, like fatalities, that we've seen in other industries, where we really learned some very hard-earned lessons on how to design an effective human-machine partnership that it's time for us to translate.
Okay, so perhaps now is the time to kind of start going into your book a little bit. So let me ask you this. I mean, my favorite sort of foundational idea that you start the book with, and that totally makes sense to me, and in an ideal world, that would be our general approach, is that robots and people, or humans, are good at different things. Therefore, the reasonable thing, the logical thing, is to simply focus on our strengths. Where robots have their strengths and their advantages, we focus on that. Where humans have theirs, we focus on that. And then we focus on how we can make it all fit together as a team. As Julie has a very nice TEDx talk about how to use robots as our teammates, so that then the final total outcome would be not one of competition, but rather than cooperation. And so we're all better off in the end. So I totally like that, but let's roll in and zoom first a little bit further. What is the overarching thesis of your book, if you have one, in a sentence or two? What's the main argument?
So I think that, an overarching theme, or at least one of the main arguments, is that in trying to envision what robots, what we call working robots, can do for us, what this technology can do for us in the future. One, this is not a technological sort of technology only issue, and that we will never quite get there. We're always trying to get there, but we will never quite get there if we think about this as a challenge of making the technology better. But much like any complex system, we have to engineer the whole system. Like we have to, in our air transportation system, there are many aspects of that need to work together. They need to be designed to requirements, so that they're compatible. We need to think about how we redesign our infrastructure, sort of the way our society functions, but also almost how we sort of conceive of how we're going to interact with these systems as something different, like something that's not fully human capable, but something that we need to work to understand a little bit so that we can almost at a personal level, but also at a municipal level, at a societal level, adapt and change so that this technology can be as useful as we want it to be. So this is the book has equal emphasis on making technology more capable as it does on making us as humans more capable of working with the technology and making society more capable of incorporating it.
Very well. So engineer the whole system together to work as a whole. What about you, Laura? What do you want to add to that?
Yeah, I think exactly that. This is a departure from how consumer products have been designed in the past, that now we have these complex, these robotic systems are complex. This is no longer, your Alexa, that you ask questions from. It's something that moves, that has a, potential to pose danger to people around it. Its decisions are safety critical decisions. And so that complex system has to be designed in a new way that factors in the people that it's going to interact with, whether they're co-located or remote operators or bystanders, has to be designed from the beginning to factor in those interactions and to design that system as a whole that includes the technology and the people as one integrated system.
I totally agree with you both on that, but let me push back here a little bit because I watched a very interesting, I think, TEDx talk by Julie, where maybe it was even titled so, or at least the main argument it seemed to me out of it was that machines can make us better humans. Is that correct, Julie?
Well, I think we should ask ourselves, like, what is our goal? And is that a goal that we should strive for? Because then other things follow from that. And I think in some contexts, I think I think in other industries we have shown that that's the case. Human pilots are able to fly inherently unstable aircraft that would not be possible without a very carefully designed human-machine partnership. And so, there are all sorts of benefits that come out of that success. And so, what is our goal in these other aspects of our lives, and how do we design to that goal?
So you see, I totally agree with you. Flying computers make pilots better pilots, and probably you wouldn't be able to fly any of the modern airplanes or even commercial planes without flying software. And the same applies to ABS systems in our cars. The same applies if you're a crane operator. You're a better crane operator if you have actually a crane than if you don't have a crane. So the robot crane, especially with some intelligence so that you don't smash into the building next to you or something like that, makes you a better crane operator. Where I'm still failing, though, is to make that jump to a better human. And that's where I'm pushing back. And here's what I mean by that. You're talking about engineer, and I think I'm just quoting from a minute ago, engineer the whole system. And your whole book is focused on engineering the robots. What about engineering the humans? We are supposed to be working as a team. We're engineering the robots to be as best as they can be. What about the humans? Aren't we supposed to engineer better humans? Let me give you one example where better robots don't do any good. There was this case of this nutcase pilot in Germany who flew a perfectly good airplane into the side of a mountain. I think he was coming back from Barcelona or from somewhere in Spain. And for a number of psychological and other reasons, instead of committing suicide on his own, he decided to take a whole airplane with him. Right? So maybe he was perfectly competent as a pilot. Maybe he was flying a perfectly, viable airplane with perfectly operating systems. And yet the totality of that complex system put together brought the death of probably something like 162 people, if I remember, or something like that. And the problem was not an engineering problem, was not a technology problem, and it was not a flying capacity or capability problem. It was a human problem that destroyed the whole system, because that was the flaw in the system. And so my concern is that if we're focusing exclusively on the engineering part of the AIs, the robots, and we're kind of not bringing along the engineering of the human part, the whole system, even if the robotic part of the system works flawlessly, we can still end up crashing into the side of a mountain.
Yeah. And so actually, we fully agree with you. And in fact, I think, many aviation accidents are attributed to human error. Many automotive accidents are attributed to human error. But my background is also aerospace engineering, and one of the human systems engineering classes that I took and that we teach, a common thing we do with the students is actually study NTSB, accident reports, and when you look at the what you see as that terrible tragedy actually has sort of many layers to it that results in that sort of terrible tragedy at the end. And there's this model that we reference in the book, the Swiss cheese model, where really for something like this to happen, you almost have to have all of these different layers, the human actions, the technology, but also like organizational, other sort of structural influences. And you have to sort of navigate through all of these holes. It's like highly unlucky, right? And you have all these layers to be able to sort of catch these issues, and then your accident occurs. And there's a human aspect to it. There's organizational, institutional influences as well. So, for example, in some fields, seeking help for sort of mental health issues is discouraged, right? And that can have implications for your career. That's an organizational influence that could set you up for sort of a terrible tragedy of the type that you're referencing here. And so actually when Laura and I sort of talk about we need to design the full system, it's also thinking about these larger societal sort of contexts. And so I think we're sort of in full agreement. There really is no sort of simple engineering solution for many of these things. And humans are complex. What does it mean to make a better human? Well, that's an ill-posed question, unless you're looking at one specific aspect of what makes us.
Well, the study of ethics is exclusively focused on that specific question.
Sorry, say that again?
The study of ethics is specifically focused on the idea, what does it take to make a better human?
Yeah, and if I could add to that, I mean, I think
Please.
I think that our view is that robotics and autonomy, AI, is if we design it properly, it can be designed to provide more protections, plug more of those holes that Julie referenced in the Swiss cheese model, to guard against areas where humans may make bad decisions or make errors without intention. And certainly I think what we see over time is that, we plug some of those holes, we try to plug as many of them as possible, and we advocate for, in new applications, to look at analogies and other applications to not have to find those holes, but to, try to predict where those holes might be and how we can plug those from the start. But then absolutely, in real life operations, new holes pop up that maybe weren't intentional. But you mentioned the one that suicide into the side of a mountain. Certainly, that probably was never imagined by the designers of that cockpit automation, that a person would make that type of in some ways a failure mode of a person.
And he even locked out his co-pilot, sort of pushed him over to go to the washroom, then locked himself into the cockpit. Then the other pilot desperately tried to break into the door, but they're all hardened now since 9/11. And so he couldn't break in. And by the time, it was over.
Mm-hmm. But I can also say, I think there are many great examples where technology maybe has helped, prevent these fatalities. I can say, having studied, air traffic control for a period of time, in that case so in some ways those air traffic controllers are like remote monitors of these these complex systems that are piloted, but still they are responsible for the safety just as much. And having things like TCAS, the traffic collision avoidance system, in place to catch things that the air traffic controller may have missed, helps preserve mental health and helps save lives. So there are certainly always new things, new failure modes that we might not predict, but it doesn't mean that we shouldn't try. And I think that's our big message, is that when designing these autonomous systems, it's critical that from the beginning we think about what are the potential holes, the potential failure modes that could happen, and how do we build in these layers to, crossing technology, people, infrastructure, remote operation. How do we build in those layers to try to protect against those failure modes, so that, again, we don't have to rediscover those. And when we do discover ones that weren't seen before in this application or another application, then then we try to come up with a new solution. But again, for me, it's not enough to say there will always be additional failure modes that you can't predict. It's still the responsibility of the technical community to try to design solutions, and not just the technical community, the policy community. All the people that are involved in creating the environment for these autonomous systems to be as successful as they can be.
Let me push you a little more here, though, because I don't think we're quite talking about the same thing here. And the key word here is failure mode, right? What is a failure mode? Because my concern is that the system can be flawless in theory, not that in reality it would ever be. But let's say in theory, there's no such holes that you've mentioned. It's flawless. It could act perfectly as designed, and yet it could lead to our ultimate destruction. And what I mean by that is this. Take nuclear weapons. You can have a bunch of scientists, the smartest people around the world, Oppenheimer, you name them, all of them, right? And they can design the best possible system to, let's say, prevent accidents. Let's say prevent mistargeting. And yet, if the system works flawlessly, when some human presses a certain button, we would all be dead. And the system would have worked flawlessly, and yet we would all be dead. Why? Because we are talking about a total system where the robotics, the mathematics, the physics, the chemistry, the sort of mechanics of it, everything works, and it delivers what it's supposed to deliver. What's supposed to happen happens, and the outcome is we're all dead in the end. And so you have a system which ultimately works as designed, but the outcome of that system is, to say the least, suboptimal. It's kind of like game theory, right?
Absolutely.
And the weak link of that system is presuming that your robotics and AI end of it works flawlessly, which is a big presumption, to be honest. But let's presume that. The weak link of the system is humanity, is what I'm trying to say here. And therefore, I'm concerned when I see some expert like you, who is infinitely more knowledgeable than me, who says machines can make us better humans, because from my philosophical points of view, garbage in, garbage out. And I'm concerned that technology acts as a magnifying mirror. And we can see the effects of it even right now, today, as we speak, during the American election. We saw it during the past American election. Right? You have this super powerful technology, you name it, AI, social media, the internet, nuclear weapons, physics, breaking the atom apart, quantum mechanics, space flight. And you can say you can send rockets to Mars, or you can send them at your neighbor. And that's not a malfunction of the system, that's a malfunction of the human end of the system. So my concern is that if you're building a such system which works flawlessly and you're not concerned about the human element, should you not be a little more concerned about that? And should you not take some responsibility? Because Oppenheimer, for example, became a pacifist and said it was all a mistake in the end. right? And now there are people who are saying that AI and robotics are equally powerful, Elon Musk being one of them, equally powerful as nuclear weapons. They're the nuclear weapons of our age, and they can save us, save millions of lives. You know, as you said, 1.2 million people die in car accidents around the globe today. You have, especially if you're in Canada or in US like we are, we have better chance to be killed on the road than anywhere else pretty much. And yet, the downside is if we get it wrong, we can end up somewhere pretty bad.
Yeah, I mean I think you're bringing up a key point here, which is there's one lens that we need to put on to think about what happens if with the technology fails, what happens if it doesn't perform as we expect. Are we how are we addressing that? And we do spend a fair amount of effort in the book working through and thinking through how it is humans can shore up the capability of the system as well as vice versa. But then there is, this separate question, which is equally important to ask and address at the beginning, which is what happens if your technology works exactly as you expect, and it exceeds your wildest expectations about what can be accomplished by developing the system or deploying the system. And then what happens then? Like what are the ripple effects of this? What are the ways in which this technology can be repurposed for different tasks or applications than the one you initially developed it for? At MIT, we're putting on my associate dean's role in the college, in the Schwarzman College of Computing. We're working to deeply embed social, ethical, policy questions and considerations into the technical curriculum. And these are actually questions that we ask our students. So, not just what happens if the technology fails, but what happens if it succeeds beyond your wildest expectations. And in fact, one of the prompts that we give the students is, what Black Mirror episode would you write if this technology was, as absolutely successful as it could possibly be? And it's important to bring our full technical creativity, but also our creativity in thinking about these possible outcomes and consequences as sort of a key part of the bread and butter of what engineers and technologists do. And so I think you're spot on that's an equally big threat. And so now I'll just ask the question for Laura and I to banter and think about. I think in part, I think the book is motivated by asking the question, what if these systems that we're now seeing, security guard robots, sidewalk delivery robots, robots in our grocery stores are end up being so wildly successful. So first of all, we spent a fair amount of time talking about why they might not be and how we need to get on designing these systems so that they are, so that we can see their benefit. But these systems sort of deployed at scale in all of these different sort of pockets and aspects of our life can have very significant negative consequences. Right. Questions from who has access to the technology, who benefits from it, who is differentially impacted, where are these technologies tested, say. Maybe if it's, I'd like to joke, if it's one Roomba, hitting your ankle in your living room, it doesn't understand you, doesn't see you, it's not, you're probably not going to trip over it and everything is okay. But once it's 10 Roombas across your whole house or, similar systems, in effect in some way, or they're kind of bumping into you, now you have a bigger problem. And it's not just an annoyance problem. It's, I think, in large part, the questions you're asking were the original motivations of and the seeds of the book.
Yeah, and adding to that, I mean, I think we are big advocates that the policy and standards around this technology needs to be built side by side with as the technology evolves. We see that if you look back again in air transportation, there's an international community established, to really figure out the right standards, the right technology solutions to some of these bigger threats. In air transportation, it's the 9/11 scenario. It's the worst possible scenario. But there were, again, these layers of protection built in to protect from even flaws in humanity. And so I think, again, that we need that sort of side by side development of policy, that is informed by the international community, that sets that foundation for how this technology gets used, what protections are put in place, and maybe more importantly, how it's not used. We think about when you look at a lot of these, let's say, delivery robots, there's a new threat from a cybersecurity risk. A delivery truck is a closed loop system. It's controlled by the person who's driving that system. So you put in protections to make sure that person is well trained and is well rested, so they can safely operate the delivery truck. But now, if you have a delivery robot, that's controlled through a network, through the cloud or a cellular network. And there's an inherent, cybersecurity risk. It's something we take very seriously. Emotional, but there aren't as robust methods or discussion around topics like that yet. That again, we advocate that those are the kinds of things that we need to grapple with and figure out before they become a problem.
Very well. Let me ask you, because you just mentioned Motional, and that's very interesting cutting edge work that's been taking a lot of headlines in the last couple of years. Most notably, Elon Musk again proclaiming multiple times that we would have fully autonomous self-driving Teslas by 2020. So I think we are in 2020. It's almost over. Where are the self-driving cars? And if fully self-driving cars, I mean, and if they're not here yet, when can we expect those? Because, as Peter Thiel once said, we were promised jetpacks and we got 140 characters. So his buddy Elon promised us self-driving cars in 2020. And last time he said something like that was maybe a couple of years ago only. And yet,
Yes.
Just yesterday, I was watching a Tesla fail the most winding road down in San Francisco multiple times.
Nice.
Actually, which was a very cool, interesting video. So what about that, Laura?
Yeah.
Are they here? And if not, when should we expect them?
Yeah, I mean, look, I think, developing self-driving cars was maybe harder than first expected. What to expect, the expectations were not properly calibrated. I think we have recalibrated as an industry, again, and for me, it's also looking in other industries, that I do think that this is the year, and we are starting to see that we will see driverless technology at small scale. I think it's not a problem that you wake up one day and it's solved. It's, you start with a focused, again, back to Julie's point earlier around structuring the problem. So you start with, a set of use cases. We call them ODD and the operational domain description in autonomous driving, but you start with lower speed. You start with, areas where there's maybe more structure around the intersections, fewer, no school zones, for example. So fewer maybe vulnerable or unpredictable pedestrians. So it's not like you're going to wake up and it's done. If you look at what others are doing, it's happening in sleepy towns, sleepy suburbs. We have a driverless capability we're working on that will be complete by the end of this year. So we're starting to see companies pull the safety operator out of the driver's seat for the first time this year. But my perspective, it's only the first part of the journey to truly realizing driverless systems at a scale that's going to have the kind of impact that we imagine it, but you have to take a first step to get there. And so for me, this is the year of that first baby step. And I think over the next couple of years, we plan to have our first commercial driverless system, developed by the end of 2022. So it's really, it's a process. And when we look at other industries, that's usually how it's gone. It's not like you wake up one night and it's done. It's more about taking those steps to getting there, starting very structured, expanding to less structure over time. But again,
let me ask you just to clarify what you mean by driverless specifically, because there's many different definitions, and then we'll move back and actually talk a little bit about what do you mean by robot and what do we mean by artificial intelligence, because those are important terms. But let's talk about first about driverless or self-driving car. What exactly do you mean by that? And once you define that, and you can both take a shot at this, what's the timeline that you project as an expert in the field that we would be expecting one or many?
Yeah. So driverless, yeah, you're right that not all driverless is the same. When you hear of companies talking about full self-driving, I think that's Elon Musk's term, FSD. So driverless means you have a vehicle that's fully, in control of all the safety critical functions of driving that vehicle. Now it still can get, it can have a somebody who's monitoring either in the vehicle with a big red button to stop the car. Behind the vehicle, you often see the thing that isn't noted in many of these articles is there's often a trailing vehicle with, again, a big red button ready to stop if, let's say, a kid chasing a ball runs out into the street, or you can have a remote operator. But driverless means that, the driving task is fully being, the safety critical part of that is being closed by the autonomous system on board. Now, we have an autonomous system that's in operation today on the Lyft network in Las Vegas. There's a safety operator there, so that's a more there's more supervision in that task, where you have a person who's ready to take over, the steering wheel if needed. If, let's say, there's a tight cut in by another vehicle or something along those lines. So it's a progression. You start autonomous, where it's driving itself, but you have higher level of supervision, and then you start to pull the human supervisor, further from that integral driving task as you make progress.
Julie?
Yeah, I think this is this is sort of the natural progression of the technology. I mean, I think of the analogy to a human driver, doing driving school, and if you remember you may remember way back when, but the sort of instructor when you're learning to drive has a brake over in their passenger seat. It's sort of, and you start by bringing the student to easier, lower traffic places where they're familiar, and you sort of build up the skill set sort of step by step. And so I think this is a process we're very familiar with pilots. Sorry, go ahead.
So when can we have the student without the instructor, without the brake? Because to me, that's what self-driving car or driverless car means, or should mean, because like on purely linguistical basis, from a language point of view, driverless means there shouldn't be a supervisor or an inspector. That's the ultimate goal I think we're going for here, right? So how far are we from that?
Yeah, so I mean, today, I think, as we mentioned, this is sort of the year where we're seeing these truly driverless systems start to become a reality, but you can't remove the person with their foot on the brake or ready to hit that red button, whether it's, again, in a remote operating center or trailing car. You don't want to do that until you gain confidence, right? You need to drive a lot of miles with this driverless system before you're ready. Just like with a human driver, we teach them, they go through tests. We have similar things in engineering, where we go through a lot of validation, and there's a lot of rigor there. Before you would want to remove a human supervisor from being able to intervene. Again, this is pressing the brake is much different than taking over the steering wheel and performing part of the driving task for the system in a manual way. So I think it's a part of the progression. So if you're asking for my prediction, when do we remove that brake pedal somewhere in the loop? I think that probably is likely to be still a ways off. I would say a couple of years. I think we need to see this technology in operation, get get a lot of experience with it, have results, work through some of these kinks we talk about in terms of, people interacting with these autonomous vehicles, and, rare scenarios that only pop up when you experience when you have a lot of exposure of the system, to a dynamic world. Only then is it responsible to remove, a human supervisor from being able to, monitor and stop a system if in case of an unexpected situation.
Do you agree with that couple of years, Julie?
I hope so. I think it's possible. I think in my mind, one of the key challenges is that when you're a flight instructor or a driving instructor, and you're trying to gain a sense of the capability of your student, that student is another human, which is likely to make the same errors or have the same or does have the same sort of underlying hardware and software that you do, the same biases and heuristics, and that instructor usually has a lot of experience, learning the learning curve of another human. And this technology, I think, we don't have that same experience with the learning curve, and the errors it makes are maybe rare errors and maybe very different than human errors. And that makes it very hard to think about like licensing or, going through the same process that a human would go through to sort of certify the capability of another human. And I think these are challenges that we absolutely need to address, and being able to address them is going to transform the entire field of robotics and the use of these systems in society. So I'm not of the camp to say like this can never be done. I think this is something that companies like Laura's are leading on, and I'm very, very eager to. And there's excellent work in academia on sort of trusted autonomy and verification and validation of these technologies that is going to move this field forward rapidly too. And so I don't think we would have written the book if I would not have written this book with Laura if I did not think that this was coming imminently. So
imminently, yeah. I love. First of all, I agree with you that that's a good problem, and it's an important problem for us to solve, because, as we mentioned, 1.2 million people die. That's not even mentioning the maimed and the other injured people, and time saved, efficiencies, and endless benefits of actually introducing that kind of a improvement. But the reason why I'm pushing so much to define our terms is that so that we can kind of better judge your guesstimates. And here's why I'm doing that. I rode in one of the first, if not, well, the first one was a Mercedes in the 80s, so forget about that one. But I rode in a Prius in 2011, which was at the time probably the first self-driving car in the United States, or in North America anyway. And the experts that were showing me that car around and explaining the LiDAR and all of that, which was basically a modified Prius at the time, were kind of giving me the same estimates that you're giving me now, a couple of years, right? And that reminds me to the fact that Marvin Minsky famously said that computer vision would be resolved by an undergraduate summer student, over the course of a summer. Right. And within, a handful of years, we would have solved basically the problem of artificial general intelligence. Right. And here we are 50 years later. And the reason why the definition is so important to me is because I disagree with you as per what self-driving car means. And here's what I mean. I think you guys are engineers, so you're cheating your way out of the problem, which is totally legitimate. But if you put the LiDAR, a bunch of sensors, if you pre-drive the course 1,000 times, and if you include all kinds of infrastructure worth billions of dollars ahead of time to make your car work, that's not really solving the problem. That's like cheating yourself out of the problem. To me, a self-driving car...
I'll push back on that. Yeah,
sure,
yeah.
Sure. Just give me a second. To me, a self-driving car, I would recognize you have a self-driving car is not if you take me on NASA's Ames campus and you drive me around in a Prius in 2011, but if you take that car in Bombay and you drop it off on the road with no traffic regulations, with a donkey, with a bicycle, with a little scooter, with cows everywhere, with no police officers, with no registration, and a million things happening unpredictable all the time. And if you are able to drive from one part of the spot or in the middle of the desert, if you will, or in the jungle or something, and if you're able to do that kind of driving, I'll be like, here, now we have a self-driving car, because that's what it means to me.
So
Where am I wrong with this?
I think, yeah, I mean, if that's how you frame your goal, I would just push back and say that that's not the appropriate goal, because like, do we let 16-year-olds out on our street and obscure all of the traffic lights and traffic signs and lane markers, and do we take away their GPS and their map and then say, okay, this is how we know if you can really drive? Like, we design, we develop our infrastructure to support a safe transportation system, whatever transportation system that is.
But you both have worked for the military, and you know that soldiers have to be able to make do with maps, not just with GPS, right? So they have to be able to make do with technology and without technology.
They also train very, very intensely for that specific purpose. And so if that is the ultimate objective of what we need of this technology, then we develop towards that. But I think it creates sort of a very long horizon under which we can expect to see the benefits of that technology, when it's our bread and butter to to design like rules of, develop rules of the road, set up infrastructure. We're constantly refining, crosswalks, right? And like bike lanes as we see, terrible accidents unfold at them. There's a constant sort of revision of the structure that we give to even our own sort of human behavior, on a day-to-day basis. And I think we need to expect that we do that same thing for these systems to be able to make use of them, as we would hope to. And frankly, as I would have hoped we would have been able to in this pandemic, when it's unsafe for so many people to be doing things out and about. And so I think if we had gotten on this even a few years earlier, and so let's make it happen for the next pandemic, shall we?
Yeah, and I think that's, for me, a part of this journey. I think we cover this sort of timeline of like automation invasion. Where did this all come from? And it's, that vision that you paint of take a vehicle that we developed here in the US and drop it into any country with completely different, maybe instead of, right-hand driving, it's left-hand driving, and, any sort of scenario, and donkeys on the road, and new kinds of scenarios that weren't envisioned from the start by the designers of the system. That vision is very far off. But it's not like we won't have anything until we get to that. For me, it's again this sort of journey you have to go through. That's ultimately, where we'd all love to be, to have this general solution that can apply, that you design once and it applies anywhere. The reality is we're far from that. That I'm certain of. We start with very geographically focused area. And again, it's a safety critical system. This is, it's dangerous if it doesn't perform flawlessly, if it doesn't have a good understanding of its environment and the rules of the road. And so all of that gets encoded into how we build the technology, where we train it, what data we use to train the system, what's the decision-making hierarchy. All of that is a part of the solution. So it starts with a very structured, focus on a geographic region, a set of use cases, and then you build it from there. You start to generalize it. Okay, maybe now it can do any urban setting in the United States. Okay, now maybe it can do any highway, any road in the United States. Now it can do any urban setting in a certain part of the world. You build it up over time. It's not like kind of a single solution that solves all problems at once.
And I might just jump in to add too. I've heard sort of echoes of the argument you're making, over large portions of my career working in human robot interaction. So, sometimes, you think of, designing for human robot interaction almost as the cop out. It's like you're almost giving up on the technology. The technology can't do it. So let's make it easier for the technology by bringing the human into it. And for me, I think there's a place for trying to develop technology that's more independently capable, but ultimately human robot interaction is the goal, right? So we're designing for the goal. We're not trying to take some easy route in or a shortcut in or sort of giving up on the technology itself. And I think we make an argument in the book that goal of human robot collaboration is so sufficiently different than the goal of an independently capable system that unless we're thinking about that at the beginning, we won't achieve this benefit we're hoping to achieve from these systems sort of integrated more broadly into society.
But the question then is, and that's where the importance of definition is so important, and the importance of goals. That's why I always say the why and the so what are the most important questions, not so much the how, to me at least, right? Because the goals are crucial here, right? And here we have clear differences of goals. And I think it's not unreasonable to presume the following. John McCarthy defined AI as the science and engineering of making intelligent machines, to the point that they would be able to perform equally as humans. And so extrapolating that into the car realm with self-driving cars. And by the way, the crux of that issue we have right now is also the crux of the issue that European Union has with Elon Musk, and why they cranked up on his claims about autopilot and self-driving. And they rated his car very high, the highest actually, but they said he's overblowing his self-driving and autopilot, right? Because the presumption is that if you take a human being and you drop them in Mumbai, or you drop them in Latin America or in Europe, they'll be able to drive on a road they've never been on before. And the presumption is that artificial intelligence would be equal or better than humans. And the presumption is, so you tell me where my logic is failing here. And the presumption is that a self-driving car would be equal to a human driver. So if a human can drive in North America, they'll be able to drive in India. Maybe not perfectly, not flawlessly, but they will be able to. But the problem is that if you have a car that drives only in North America and not in India, then that's not a self-driving car. That's a car that drives in a very specific context, in only one specific condition.
I've been to India. My husband's family is originally from India. I've driven in North America. I have been in a car on the streets in India. I could not drive there. I don't understand. Like, as far as I could tell, there are no rules. There's clearly norms and ethics there to navigate those intersections that I do not understand.
My
and
point
an AI
precisely.
cannot be expected to do it either safely, right? I mean, at least as safe as people do it, without any sort of structuring of that problem, without any sort of data on how folks drive in that area, or some other sort of structuring or priming of the problem for it. I don't think that's the goal for us. I don't see why that ought to be the goal for these systems, because there are so many other goals that could add value so much in the near term, but that are not easy. Like there are like deep challenges associated with these sort of safety critical systems on our everyday roads, even when they're navigating the same neighborhood day after day. That we don't want to miss. We don't want to, be looking at this sort of far off goal, which is a good reach goal to maybe advance technology, but miss the key things we need to be working on now to make this technology something that's useful in the near term.
Okay, so let's move on from here. Let's talk about some other definitions which play an important role here, and let's ask, what is a robot? Because your title is all about robots. What to expect when we're expecting robots. So first of all, what is a robot? How do we define one? And do you have that definition in the book? Did I miss it?
So let's see. I will give you what the IFR, the International Federation of Robotics definition of a robot, I think is a system with, I think they say three degrees of freedom, 3 axes. It might be 4. I refer to something with 4. But is an airplane a robot? In my view, yes. Is a smart home a robot? I say, yes, it is. So, systems that are that have embodiment and that act in our world, that take in information online, act in our world. We're talking about intelligent robots there. You can have sort of a standard industrial robot that is not intelligent, that's not necessarily responding to its environment in a dynamic fashion. But for Laura and I think the book is focused on what we call kind of working robots out in our streets, in our homes, in our workplaces, embodied systems, taking in information about the world and acting physically in it.
Laura, do you want to add anything?
No, I don't think so. I mean, and I think one of the coming back to our previous discussion, I think a robot still can have supervision by a person. So Julie mentions an intelligent robot. There are certainly remote controlled robots. We're really not as focused on that. We're more focused on as you pull people further and further out of those inner control loops. So now you have the human really transitioning to being a supervisor or a bystander in many cases, and that can be co-located or remotely located. So there's different forms of supervision based on kind of the capabilities and the intent of the robot's objectives.
And did I miss that definition of robot somewhere in your book? Did I miss that?
I do not believe we pull the IFR definition of a robot.
Or any definition for that matter. Isn't that strange? You're writing a book on robots and you're not even defining what a robot is.
We give lots of examples. We give lots of examples in the book, which
describe the components of a robot, certainly.
Yeah, than talking about numbers of degrees of freedom or,
Here's why I'm pushing for that here, okay? Just so you understand my biases. I've done 260 of these, and generally they're very much about artificial intelligence, robotics, etc. And I've done all kinds of experts. Among these 260 interviews, not 2 definitions of artificial intelligence have overlapped so far, right? And Marvin Minsky, Ray Kurzweil, I talked to Professor Stuart Russell, who says, of course, well, the definition of AI is in my book. My book is the standard textbook. Go and read it, right? And I was like, and he got quite upset with me. Well, not quite, but a little kind of annoyed by me by saying, look, but I've interviewed 250 other of your colleagues and not one of them mentioned the definition from your book, right? And my concern is, as an outsider, you guys are all insiders, that when you're defining things that mean different things to different people, you're talking past yourself. And that's less true about robots, in my opinion, but more true about AI, because AI is so vastly different. Because like people say I work for Google in their search engine and I work on AI, and people say I work in aerospace industry for AI, in cars for AI, in object recognition, voice recognition, and everyone works on AI, but it's got nothing to do with anybody else's AI, and so they talk past themselves what's actually AI. And that's why if we want to actually have a conversation, we have to make sure we're talking about the same thing. And that's why I like to pull out of people, if I can, a definition so that we, the outsiders, get an idea about what we're talking about.
Absolutely. So I guess I have a story that I tell to my students, but I may as well just tell it to you and the whole world. So when I was a brand new grad student, just starting in the field of AI, I went to a conference, and I remember at the end of, I don't know, the second or third day, there was this plenary session, and it was labeled something like, "What is AI?" And I thought to myself, this is really great, because if someone asked me to define AI, I'm kind of new in this field, I'm not sure what the precise definition is. And so I went and I sat down, I'm like ready to take notes. And then what I realized there's a few people who are the top in the field, and they're up there debating the definition of AI. And I thought to myself, oh my gosh, they don't even know what the definition of AI is. And so, and I think that's sort of I'll just add, one other story or joke, which is this was also told to me, when I was sort of brand new in the field, is that AI researchers always kind of have a little bit of a chip on their shoulder, because we're always working on something that almost works. That's what we call AI. But the moment something works and it becomes sort of embedded in society, like it doesn't matter if, the field spent decades working on it, nobody ever considers it AI anymore. It's like, oh, that's not AI, and so, I think grappling with this definition, and there are some that some definitions that I sort of refer back to, but they're probably wouldn't be satisfying to you because what makes something AI? There's no simple linear sort of scale for that. It's sort of multi-dimensional. It's like a calculator AI. Well, it's a matter of scale, right, and of the particular dimension you're considering it on, especially if you're overlaying that on, and your comparison is human intelligence. I think it's a complex question. It doesn't lend itself to a very simple and easy answer, and that's why we revisit it so often.
And that's why, I wanted to ask to find out if it's deliberate or kind of random that there's no definition, because Gary Marcus, for example, deliberately did not put a definition of AI in his latest book. But speaking about the book, Laura, can you tell us who your book is intended for? Who should read your book, and what should they expect to get out of it?
Yeah, that's a great question. And it probably comes back to this, why didn't we include the robot definition question, which, we grappled when we started this project with who should we be trying to reach. We had a lot that we wanted to share with detailed, engineers who are and research scientists who are working on these problems, in great detail. And so, we grappled with, is that our right audience, or is it a broader community who might be CEOs, might be users of this technology, might be policymakers? And we ultimately went that direction to have to make the book accessible to a broader audience who has a general interest in technology, but also tried to include some nuggets that would also provide some new contributions to the detailed technical audience. But yeah, we assumed some basic understanding of robots in our audience. We assumed people would pick up this book if they had an interest and were enticed to learn more about what's happening with robots today and where are they going next. So I don't, I think we dived in, we focused our deep dive instead into here are the different parts of a robot. Here's how, the different levels of supervision a person can have. Those were more the areas of focus rather than building an initial foundation of what is a robot. We assumed, again, that our readers would have a general understanding of what robots are, but want to learn more about, okay, we've been hearing about them for years. They're going to enter our world. Where are they? And when are they coming? And what is it going to mean? What's it going to look like? And we wanted to break down some of those previous, notions of what these robots might look like. They're not going to look like another person. They're going to look different. And they're going to do things, they're going to be designed to do a task that's going to help you, or should be designed that way, rather than something that's going to be social and really replace a human in your world. It's instead there to help people around them. That was we were trying to reach a broader audience than just engineers.
So the two, in the interest of time, because I know your time is very precious, so we probably have the last 11 minutes here of our interview. So the two favorite things that I took from your book are, I already mentioned the first one, was the fact that robots are good in one thing, people are good at another thing, and instead of trying to replace one with another, we should just focus on the system and engineer the whole system, as Julie said, and focus on our strengths and focus on the team building aspects of both parts of that. So I love that. And the takeaway note at the end was that, quote, we believe that what to expect when you're expecting robots is that they will not work for you anymore, but with you. So I love that too. And that's very well said. But talk to me a little more about the dynamics here of this statement and about the likelihood about this, because just yesterday I was reading a piece from a bunch of previous ethical or insiders or whistleblowers from places like Facebook and Google, who basically wanted to create a derivative of that so that we work with social media, Facebook, YouTube algorithms, you name it, and it works with us instead of for somebody else. But every time they try to do that, the systemic setup of capitalism and of a corporation makes it so that that's literally impossible. They run into the corporate wall. And so you can say, well, it's all nice and good to enhance humans, but you can say the market incentives are to replace humans. And in your book, you give a lot of examples about, or you mentioned, and Julie, you mentioned in your research to scheduling software, and we know how scheduling software is supposed to make things better and easier and so on. But we also know that, the New York Times had this huge article about clopening in Starbucks. And that was 8 years ago, how women are forced to close and open at 5 o'clock on the next morning, and how people are cut off at 30 hours automatically so that they can't get any benefits. And all of that things now being automated with the software. Right. And 8 years later, they did a follow-up and nothing has changed, even though Starbucks very publicly went and said on the record, we're going to change this. And they didn't. Right. So again, example of smart software supposed to work with us, and yet it doesn't even work for us. It works for somebody else entirely. How do we change that? Because that's the biggest, to me, the issue is not technical. The issue is commercial. It's systemic.
Yeah. So, I think you're again raising, I think key points that we do touch on in various ways in the book, and there are incentives. There are particular, goals behind the development of technology. There are winners, there are losers associated with it. And it's not just a technological issue. I think one of the,
it never is a technological issue. That's the whole point I'm pushing for the last 11 years, right? And that's where we're kind of disagreeing on. It's never about the technology. At the end of the day, it's always about something else. Look at Vietnam, look at Afghanistan and Iraq. All the technology in the world didn't help one bit. Trillions of dollars didn't help one bit. Only hundreds of thousands, if not millions of people dead. In the case of Vietnam, millions of people dead. And we had a feudal country that was at war with the biggest war machine in the history of the world. Didn't help either.
Yeah, and I think our counterexample, again, is air transportation. There's, again, the international component, a lot of cooperation required, a lot of infrastructure, a lot of investment, globally. And yet, air transportation is the safest mode of transportation today, even though it relies heavily on cooperation, humanity, a lot of people doing the right thing, making the right decisions. It's not flawless. Unfortunately, nothing is, but I think it's a great counterexample of where, technology can be designed and deployed in very helpful ways to society. And so that's why we kind of use that as our anchoring analogy of what, we should learn from what went well there. And you talk about capitalism and kind of the motivations and incentives, in tech companies. And we saw this in air transportation. The creation of the FAA happened because you had the CEOs of the airlines and the aircraft manufacturers come together to say, this is what we need. We need cooperation across the community. Safety transcends competition in this case. And the only way to get there is and I guess my personal belief too is that companies who get this and who think about that and factor that in from the beginning will succeed ultimately. That these things, maybe they don't play out initially, but they play out over time. And, the people who, again, the companies who are thinking this way and pushing in this direction, will succeed in the long term.
These issues are absolutely intercoupled with the technical issues as well. So, I think, as we all know, data is, a key aspect to developing these systems. It's not the only aspect, but it is a key aspect. And, on the aviation side, when there's an incident of some sort, we have mechanisms for sharing that information through anonymous reporting systems. that are a key factor in the increasing safety of our air transportation system. But we don't have that mechanism currently. For example, for one manufacturer of one robot system or autonomous vehicle to be able to be able to provide the relevant information around some incident so that another company can learn from it. And there are many, this requires a public-private partnership of some sort, as it has for aviation and other industries. Is what we what we indicate in the book. But there are deep technical challenges with doing that too. It's not as simple as a pilot, reporting on a form, the context around the occurrence, because the data sort of captured by one vehicle is intrinsically linked to the sensors and the capability and the algorithms of that vehicle. And it's not easy to set up a new test case for another company to sort of try to prove out that their system doesn't have sort of a similar flaw. And there are AI and AI engineering challenges associated with even making something comparable to what we do in aviation today possible on the on this sort of robot side.
Aviation industry, I have to kind of give you half and half there, because I just watched the whole documentary on Boeing and about how they knew all the problems ahead of time with the 737 MAX, and even the safety inspectors were internalized or outsourced from the supervisory agency to the Boeing company, which is to say their bosses would tell them if they're allowed to say that the plane is unsafe or not safe, how the whole system was designed to hide all those issues, how after the first accident it was hidden, how after the second accident there was a very serious attempt to hide it still again. And only due to a number of other factors did it came out to light. And when it came to light, it was much worse and much more of a systemic failure than a technology failure. And most of it came to cost of retraining pilots, and also admitting that there were design flaws to begin with, right? And finally, take even the black box example. That technology is so ridiculously obsolete. And we have technology to replace it today very easily and cheaply, and yet we cannot find agreement so that we don't actually have to go and dig out the plane out of the bottom of the ocean to get the black box, but we have a real-time live upload of everything that's happening on the plane, right? We still can't find that inter-industry cooperation. So those are my concerns. So I can give you half and half on that. I don't know if you agree with me. But unfortunately, we're running out of time here. So I want to ask you the last two questions. And first is, where can people find more about you and your work? Because I think what you do is phenomenal, despite of the fact me pushing back. And I think you would be the ones who would be sort of the decision makers and the creators of those technologies, whether in the civilian industry or in the military realm, quite often, as you both, I think, have or do work with. So it's beneficial for people to follow what you do because you do important work. Where can we find more about you and your work?
Well, yeah. So for those that would like to learn more about what we're up to at MIT and in the lab, you can follow me on Twitter. I have a lab webpage, interactive.mit.edu. And you can also follow, the very exciting things we're doing in the Schwarzman College of Computing, in our initiatives and programs around social and ethical responsibilities of computing. And so, yeah, I think there's increasing ways for all of us to get involved and help try to make the future that we want to see with these technologies.
And you, Laura?
Yeah, and for me, same, social media, on Twitter, on LinkedIn. We do have, we try to be very proactive about sharing developments and news at Emotional. So certainly the Emotional website, or also on social media, me or Emotional.
Okay, so the most important question, the takeaway. We've been talking with you for, let's say, an hour and 30 minutes or so. What's the most important thing that you want to send us away with? whether about what we should expect when expecting robots or anything else related to robotics or artificial intelligence or even technology in general. What's the one thing that you want us to remember from this conversation with you? So let's start with Laura.
Yeah, so I mean, I think for me, the one key takeaway is that it's these big long term questions of where will this all lead and when will we get there. Those are important, very important questions. But I think our contribution and our focus, at least for this book, was more near term. There's a lot of work to be done here and now to get this technology off the ground and get it integrated into society in a way that's helpful today and in the upcoming decades. But certainly we have these longer term issues to work through, but our contributions is really about how do we create that human system partnership to get these systems to be effective and safe in our everyday world today.
Julie?
Yeah, and I think I just add to Laura that we all have a role to play, like not just us as technologists or academics or those in industry, and not just policymakers, but literally every one of us needs to be working and thinking and contributing about how we what we want to see of these systems, and we're the ones that will be the bystanders of these systems. We're the ones that will be interacting with them, and every individual voice and every one of us has a very important role to play, both in the success of these systems and ensuring that they provide us value.
And I sure myself hope that things will turn out as you hope and work towards in your book, that we all end up working more as a team, both robots and humans, but even humans with humans, so that we all end up in a better place and we are better in the end, rather than much worse off, as many experts like Elon Musk and others have been sort of worrying us about. Julie, Shah, and Laura Major, thank you very much for being with us today. If you guys enjoyed this show, you can help me make it better in a couple of ways. You can go and write a review on iTunes, or you can simply make a donation.